Hi, this video is on the second part to covalent bonding. If you missed the first part, it might be a good idea to catch up on it. But if you have some knowledge of covalent bonding already, then this might be very useful for you. Now, covalent bonds form when non-metal atoms react with other non-metal atoms. And remember, covalent bonding is when electrons are shared to gain full outer energy levels. Now, the nonmetals are on the right-hand side of the periodic table. So I'll draw that section out here for you. And so there they are. And the area shaded in grey are the metals, which we're not interested in. So the nonmetals are a small, only one element from group 3, which is boron. So boron from group 3, carbon and silicon from group 4, most of group 5 and 6, and all of group 7 and group 8. Now we're not interested in group 8 because they won't bond covalently or ionically. That's because they already have a full outer shell of electrons, and so they're already very stable, and they exist as atoms, single atoms anyway. When you try to draw the molecules of dot and cross diagrams of covalent molecules, sometimes it's not very easy, especially when there are the molecules made up of 3 or 4 or more atoms. It's not very easy to work out what is bonded to what. But in this video, I'm going to give you some information so that you get a more understanding of how many bonds each atom will form. So let's take the example of carbon and silicon in group 4. So carbon and silicon are the two non-metals in group 4. We're not going to look at group 3 because it's a bit trickier here. So group 4, we've got carbon and silicon, and just drawing the outer shell electrons, this is where the bonding will happen. So because they're in group 4, they will both have 4 outer shell electrons, 1, 2, 3, 4 for carbon and 4 for silicon. Now, to get a full energy level, they need to have 8 electrons. So carbon and silicon both will need 4 more electrons to get a full outer energy level and become stable. So they have 4 single electrons and they don't have any lone pairs. And so the 4 single electrons must be bonding to electrons of other atoms. So all these 4 electrons must be involved in bonding. So that's group 4 elements. Group 5 elements, we'll do the example of nitrogen and phosphorus. So because they're in group 5, they'll have 5 outer shell electrons. So here we can draw them in 1, 2, 3, 4. Now we start pairing up. It's very important to do this. And then for phosphorus, the same 1, 2, 3, 4, and then start pairing up. So 5 for both nitrogen and phosphorus. So they will need 3 more electrons to gain a full outer energy level and form the octet. That means that they get full 8 electrons, and they'll be stable then after that. And each nitrogen and phosphorus has one lone pair of electrons, so that one that is paired up, and they have 3 single electrons. So as they need 3 bonds, it's the 3 single electrons that will bond with electrons of other atoms and pair up with them. The lone pair is stable and therefore won't be involved in bonding. Now let's look at group 6. Group 6 elements are oxygen and sulfur. Those are the 2 examples that we're going to look at. And so they have 6 outer shell electrons, and we'll draw them here 1, 2, 3, 4, 5, 6. Remember, you start pairing up after the 4th electron. So here in group 6 elements, they will need 2 more electrons to form a full outer energy level and form that octet. So get the full 8 electrons and become stable. They have 2 lone pairs, so these are stable and therefore won't be involved in bonding, and they have 2 single electrons, and it's the single electrons, the 2 single electrons, that will form bonds with electrons of other elements, and these form 2 bonds. Now let's look at group 7. Group 7 elements are fluorine and chlorine. That's the 2 examples we're going to give. So here fluorine and chlorine are both in group 7, and as they're in group 7 they'll have 7 outer shell electrons, and we'll draw the electrons here quickly. 1, 2, 3, 4, 5, 6, 7 for fluorine and 7 for chlorine. So because they've got 7 outer shell electrons, they'll only need 1 more electron to get a full outer energy level and form the octet. They've got 3 lone pairs and 1 single electron. So it's the single electron and not the lone pair that will be involved in bonding. Now this is also true for the rest of the group 7 elements, true for bromine, iodine and astatine. So let's have a quick recap. The group 5 elements will form 3 bonds. The 1 lone pair. Group 6 elements will form 2 bonds. Group 7 elements will form 1 bond. And group 4 elements will form 4 bonds. So armed with this information, let's see if we can draw the structure of some simple covalent molecules. Let's take the example of methane. It has the formula CH4. That means there's 1 carbon atom and 4 hydrogen atoms. We know that the carbon atom will form 4 bonds. But I haven't explained about the hydrogen atoms. The hydrogen element is the simplest element, and it has 1 electron and it's in the first energy level. Now to get a complete energy level, first energy level, hydrogen atom needs 2 electrons. So this means that the hydrogen atoms will form 1 bond with other atoms. So with this information now, let's try drawing the structure of methane. We'll put carbon in the center here because it's going to form 4 bonds. And as hydrogen atoms are only going to form 1 bond, we'll put the 4 hydrogen atoms around the central carbon and see how this works. So we'll draw all 4 hydrogen atoms around that central carbon. Now the next thing we need to do is add the electrons. So starting with carbon first, carbon has 4 electrons, and remember all 4 electrons are single and involved in bonding. So we'll add those 4 electrons to each of the bonds between the carbon and the hydrogen. So the crosses are the 4 electrons that belong to carbon. And remember, hydrogen only has 1 electron, and so that is involved in the bond. So now we've got paired electrons, and that means they're stable. Now let's see if each atom has a full outer energy level. So let's count the carbons first. 2, 4, 6, 8 for the carbon. So carbon here feels as if it's got a full outer shell of electrons. Now let's do the same for hydrogen. Hydrogen, all 4 hydrogens feel as if they've got 2 electrons in their energy level, and so they also feel that they've got full energy levels, and so all of the atoms here are stable and happy. And this is because they have full outer energy levels. So now we know that this is the correct structure for methane. This is the correct dot and cross diagram. This is the correct bonding. We can now draw the displayed formula. So in the displayed formula, we don't draw the dots and crosses. We just draw the atoms, the symbol for the atoms, and we draw the 4 hydrogens next to the atoms, and we draw lines that represent a pair of electrons that are being shared. So remember, there is only one pair of electrons being shared between the carbon and each hydrogen atom. So a single line represents a pair of shared electrons. And so that's the displayed formula of methane. Now let's move on to carbon dioxide. Its formula is CO2. That means it's made up of 1 carbon atom and 2 oxygens. Now remember, from the information I told you, carbon here is going to form 4 bonds. 4 electrons will be involved in its bonding. And oxygen is in group 6 and is going to form 2 bonds. So now let's think of how we could arrange the atoms next to each other. We'll try putting the carbon in the center because it's going to form 4 bonds. And let's do that here. And we'll put the 2 oxygens on either side because they're going to form 2 bonds each. So now the energy levels are overlapping. So the first thing we're going to do is add the electrons of the carbon atom. So there'll be 4 electrons. So we'll put 2 electrons in between the carbon atom and the first oxygen, and we'll put 2 electrons in the carbon and the other oxygen. So the crosses represent the electrons of the carbon atom. So we're adding the electrons of the carbon atom only. So 2 and 2, 4. So now let's add the electrons of the oxygen atom. So oxygen is going to have 2 bonds, so it's going to share 2 electrons, 2 from one oxygen atom and 2 from the other. Now let's add the lone pairs. Now we know that carbon doesn't have any lone pairs, but there are 2 lone pairs on each of the oxygen atom. So we'll add those lone pairs to the oxygen atom. So dots for the oxygen, 2 lone pairs on this oxygen atom and 2 lone pairs on the other. Now let's count if we've added the right amount of electrons for each atom. So remember, oxygen has a total of 6 electrons, so there are 6 circles for this oxygen atom. 1, 2, 3, 4, 5, 6 electrons for the second oxygen atom. And now let's count for carbon as well. So carbon has 4 electrons, it's in group 4, and so there are only 4 crosses. Now the next step is to count if each atom has a full outer energy level. So this carbon has 1, 2, 3, 4, 5, 6, 7, 8 electrons in its outer energy level, so it feels as if it's got a full outer shell, so it's stable. And now let's do the same for the oxygen atoms. So each oxygen atom feels as if it's got 1, 2, 3, 4, 5, 6, 7, 8 electrons, and the same is true for the other oxygen atom. We'll just count it to make sure 1, 2, 3, 4, 5, 6, 7, 8. So each oxygen atom feels as if it's got full 8 outer shell electrons. So this is the correct structure of carbon dioxide. Now from this we can draw the displayed formula. So here we're going to write the carbon in the center. And remember, one line represents a pair of shared electrons, but we've got 2 pairs of shared electrons, so we draw 2 lines, and this is known as a double bond. So 2 lines between each carbon and oxygen. And now that's the structured or displayed formula of carbon dioxide. To turn this displayed formula into a Lewis structure, all we need to do is add the lone pairs. So there are no lone pairs on the carbon, but there are 2 lone pairs on each oxygen atom, which we add here. So that turns carbon dioxide into its Lewis structure. Now let's move on to nitrogen. Nitrogen is an element, so it's only made up of nitrogen atoms, and it's got the formula N2. So N2 is its molecular formula. So nitrogen exists as a molecule, and the formula tells us there are 2 nitrogen atoms involved in bonding. But remember, the nitrogen has 1 lone pair and 3 electrons that are involved in bonding. It's got 3 electrons in bonding, and therefore it'll form 3 bonds. So with that information, it's only 2 nitrogen atoms will be bonding to each other. So we draw the outer shell electrons. So let's add the lone pairs first. There'll be 1 lone pair on each nitrogen atom. So we can draw that in here. So crosses for the first nitrogen atom, dots for the second. So we've added the lone pair. Now we need to add the 3 electrons. The 3 single electrons are all in bonding. So we'll add the 3 electrons for the first nitrogen atom, 3 crosses, and the 3 dots for the second nitrogen atom. Now the next step is to look at, so there are 3 pairs of electrons that are being shared between the 2 nitrogen atoms. Now the next step is to see if we've not added too many. So we've got 5 for the first nitrogen atom, and we've got 5 dots for the second nitrogen atom. So we've not added too many electrons for each nitrogen atom. Now the next step after this is to count if each nitrogen atom has a full outer shell of electrons. So let's look at the first one. Well, there'll be 1, 2, 3, 4, 5, 6, 7, 8 electrons for this nitrogen atom. And let's do the second one. There'll be 1, 2 in the lone pair, 3, 4, 5, 6, 7, 8 electrons for that nitrogen atom. So both the nitrogen atoms are stable, they have full outer energy levels. So this is the correct diagram, dot cross diagram of nitrogen. Now we can draw the displayed formula for this. So in the displayed formula, you don't need to draw the dots and crosses. So you have 2 nitrogen atoms, and remember 1 line represents a pair of electrons, so we'll have 3 lines representing 3 pairs of electrons, and this is known as the triple bond, and it is a very strong bond. Now we can convert this displayed formula into a Lewis structure by adding the lone pairs. So we have 1 lone pair on each nitrogen atom. We add it there, and this turns this into its Lewis structure. So remember, from the molecular formula, we cannot work out how the atoms are bonding to each other. To find that out, we need to draw a dot across diagram, and also we can draw displayed formulas. I hope you have found out a quick and simple way of working out the bonding in simple covalent molecules.